Hello, Longhorns. Here we have the Algebra 2 Pre-AP Review 3.1, and the first thing we're going to do is factor completely. I'm going to start with question number 3, and then I'm going to do a few other questions selected from this group, and then we'll move on to a few other types of problems that you need to prepare for the test on Thursday. Okay, let's start with question 3. In this question, this looks like a special case. So remember, we do have those special cases that we learned. And this one is the difference of two squares. And you're probably thinking, but Ms. Stiles, that's an x to the fourth power. Well, it's actually x squared squared. So we actually have two squared terms here with the minus sign, which would be the difference of two squares. So this is how that's going to factor. All right, so it factors out to x squared plus 4, x squared minus 4. And if you remember from our notes that x squared plus 4 is prime, so we can't factor it any further. But x squared minus 4 is another difference of two squares. So we can factor it again. So remember, the instructions say to factor completely. Well, this isn't factored completely if we still have something we can factor, and we can still factor the x squared minus 4. So we're going to factor again. All right, so this factors to x squared plus 4, and then the x squared minus 4 factors again to x plus 2, x minus 2. Now we have completed the factoring, and this is factored completely. All right, so the next problem I want to look at is number 6, and this problem looks pretty complicated. 5x to the fourth plus 8x to the third minus 21x squared. And of course, the first thing you want to look at always is, does this expression have any greatest common factor? Is there something we can factor out of this expression before we start breaking it apart into its factors? So it looks like this particular expression has an x to the fourth, an x to the third, and an x squared. Well, it looks like we could probably factor out the x squared from each one of these terms. Now, the coefficients here, we're not going to be able to do anything with those because 5 doesn't go into 8 evenly, and 8 doesn't go into 21 evenly, so there's nothing we can do with the numbers, but we can factor out this x squared. Okay, so when I factor out the x squared, I'm just dividing each term by x squared, and when I do, what I have left is 5x squared plus 8x minus 21. And now I can just factor this with one of the methods that we learned, either factor by grouping or factor by the box method. And so I'm going to use the box method, but it's basically the same thing as grouping. I like to use it. I like it better than grouping, but if you prefer grouping, you certainly may use that format. That's fine. If you know any other formats like the California method, you can use that too. I really don't care what method you use as long as you're using it correctly. Okay, so the first step is to always multiply the coefficient in front of the x squared times the last term we have here, the constant. So a times b, a times c, excuse me. A times c is going to give me 105. I'm not really worried about the signs yet. We'll figure out what those need to be here in a second, but a 105 is the number that we need to factor. When I factor this, I find that 7 times 15 will be the combination I need. That's going to give me 8. If 7 is negative, then that will give me a positive 8. So 15 minus 7 is a positive 8. So those are the numbers that we're going to use for our middle terms. All right, so I've put all of my terms into my box, and I have 5x squared in the first box right here. That's my 5x squared. I put it here in this box. I put my negative 21 down here in this last box. And then in the middle two boxes, I'm going to put my negative 7x and 15x. Those will be my middle terms that are going to combine to give me an 8x. So this is the same thing you do with grouping. It's just a different format, but it's the same thing. Now I'm going to factor out what all of these boxes have in common, and I'm going to start with this column right here. This column right here has a 5 that I could factor out, and an x. So I'm going to factor out the 5x. And then this column right here, has a 7 I can factor out, and a negative. So I'm going to factor out the negative 7. Then I'm going to go with the rows, and I'm going to factor out what these two have in common. These two, the only thing they have in common is the x. And in the bottom, down here, the only thing these two have in common is a 3. And it's going to be a positive 3. So I'm going to say plus 3. And that'll be my factors. So 5x minus 7, x plus 3. And if you wanted to FOIL that back together, that's real easy to do. Or you can come over here and you can just multiply these terms together to see if you get what's inside the box. I always do that to double check myself, especially to make sure that I have the correct sign. So 5x times x is 5x squared. X times a negative 7 is a negative 7x. 5x times 3 is 15x. And 3 times a negative 7 is a negative 21. So I know my signs are correct, I know my terms are correct, and I know my factors are correct. So I am finished. I'm just going to put a box around my answer, and that is it. Now you may be wondering, well, how did you know it was going to be these two numbers that are going to add up to 18? 105 is a pretty large number, so how do you know what all the factors are without making this huge factor tree? Well, there's a trick that we can do in the calculator that I'm going to show you in class. And so what we're going to do is we're going to find out what the factor pairs are for 105 by graphing it. And what we're going to do is we're just going to graph this. We're going to go into f of x and graphing. And then you're just going to graph 105 divided by x. And then you're going to do a Control T. That's going to give you the table. And the table will give you all of the factor pairs, x and y, that multiply together to give 105. And then you just look through the table and you look for the combination that you need, whatever that combination is that you need to get that middle term. I find that to be the quickest and easiest way to get my factor pairs. All right, next let's look at question 8. And if you notice, question 8 is a cubic expression, not a squared. This is not a quadratic. So we have to factor this one. It's very similar to factoring a quadratic. If you use the box method, it's very easy. You can also use the grouping method with this as well if you prefer. I'm going to use the box method again. All right, so you can see I've created a box and I have put each one of my terms inside the box. The first term I put in the first box, the next term the next box, and so forth. And I just filled in my box with all of my terms. And now what I'm going to do is I'm going to factor out the way I did before. I'm going to factor out these columns first, and then I'm going to factor out these rows. And what I'm going to end up with are the two factors that I need for this particular cubic expression. All right, so that was quick and easy. I first looked at my first column here, and I noticed that I have a greatest common factor of 2 and a greatest common factor of x. So I factored it out, 2x. Over here I have a greatest common factor of 7. So I factored that out. Across here on this row I have a greatest common factor of x squared. I can divide an x squared into both of these, so x squared comes out. And over here I can factor out a negative 2, or just 2. Now the signs depends on what's in the middle. If these two terms are both negative and this last term is positive, then these two middle terms need to be negative. So that means that these terms up here are also going to be negative. So how can I know for sure that I've got the right signs? Well, if you multiply this back together, you should get what's inside the box. So x squared times 2x is 2x to the third. X squared times negative 7 is negative 7x squared. 2x times negative 2 is negative 4x. And negative 2 times negative 7 is positive 14. So I know that I've done this correctly. And now I just write out my factors. 2x minus 7, x squared minus 2. Now here's where you want to be careful, because if this x squared minus 2, if that was x squared minus 4, we would have to factor that again. So watch out for that on the test. If you have to look to see what you have left. If you could still factor something that's left, like if you end up with a difference of squares, then you still need to factor out that difference of squares. Don't forget that step. All right, for question 10, we've got some very large coefficients, and I'm going to show you a quick way to find the greatest common factor for these coefficients without having to do a factor tree. This is something that you're going to be able to do in your calculator, and I know some other math professors may not agree with me, but I'm going to give you this hint on how to do this in the calculator, because we may have a shortened period on Thursday when you have to take this test, and I want to make sure that you have enough time to finish. So any little shortcuts I could give you to help you do this test a little bit faster and easier, I'm going to do that to help you out. All right, so one of the tricks that we can do in the calculator is in your calculate screen, you can go to menu. I'm going to write this down, menu. And then you're going to go to number and factor. And then you're going to type the number in that you want to factor. So say I wanted to factor 27, and I hit enter in my calculator. The calculator is going to give me this. It's going to give me 3 cubed. That tells me that my prime factors for 27 are 3 times 3 times 3. Okay, so then I'm going to do that same thing for 276. And I'm also going to do it for 60. All right, so I've done this in my calculator, and these are the prime factors I've gotten for each one of these numbers. And so this is really important to be able to determine what the greatest common factor is. All right, so it appears that the greatest common factor is going to be this 3 here. So I'm only going to be able to factor out one of those 3's. And then the rest of it I'm going to have to leave. So let's go ahead and write that out so you can see what that looks like. And I'm also going to factor out this negative sign right here. I don't want that when I'm trying to factor the rest of the expression. So I'm going to factor out the negative sign, and I'm going to factor out a 3. Okay, so I factored out a negative 3, and what I have left is a 9p squared, because 27p to the third divided by negative 3 gives me 9p squared. And then this positive sign changes to negative, because when I divide 276p squared by a negative 3, the sign changes. So that becomes a negative 92p. And then the last term, oh, I forgot to factor out the p. If you look here, you can see that there's also a p, greatest common factor of p here. We need to factor that out too. Okay, so I've put it in here. There it is, p. Oops. All right, so 9p squared minus 92p plus 20. So when I divide 60p by negative 3p, I get positive 20. So this is what we're going to end up having to factor again. Now we've already factored out the greatest common factor. Now we need to factor this. So I'm going to move the screen over a little bit so I'm going to factor it over here on the side. Okay, so I've done quite a lot of work here. You can see that I've rewritten the problem right here, negative 3p times 9p squared minus 92p plus 20. Now I had to multiply the 9 times the 20 to get this 180 right here. And I needed to find the factor pair that adds to give me a negative 92. Well, 90 times 2 is going to be 180, and negative 90 plus a negative 2 is going to give me a negative 92. So I'm going to write those here in these boxes right here. Okay, so when I factor these out, I get a P here, and I get a 10 here, and that's going to be negative. And then when I factor out the row, I get a 9 and a P. And when I factor out the bottom row, I get a -2. So let's just multiply these back together and make sure it's correct. Okay, so P times 9P is 9P squared. Negative 10 times 9P is negative 90P. Negative 10 times negative 2 is positive 20. And P times a negative 2 is a negative 2P, so we're good. So we can finally write our answer, negative 3P, P minus 10, and the other factor is 9P minus 2. And we don't have any other special cases here, so we are done. And that's it. All right, for number 11, we're going to first find if we have a greatest common factor that we need to factor out from these two numbers. This appears to be a special case, the sum of cubes, but we need to make sure that the coefficient here, 81, is a perfect cube, and it is not. So there's probably some number that we need to factor out. So we're going to use our calculator or factor tree and find those prime factors and see if there's anything we can factor out. Okay, so I found that 81 is actually 3 to the 4th power, and 375 is 3 times 5 to the 3rd. So I think we are going to need to factor out this 3. All right, now we have 3 times 27x cubed plus 125. So the one thing that you're going to have to be able to do is you're going to have to be able to recognize when you have the sum of cubes. So 27 is a perfect cube, x cubed is a perfect cube, and 125 is a perfect cube. So if I take the cube root of these, I will get 3 for my cube root of 27, and I get x for my cube root of x cubed, and I get 5 for my cube root of 125. That is going to be my first term when I factor this out. Now the other part of this is going to be, if you remember what we did in class, it's square, multiply, square. So square, multiply, square. And the sign here is going to be the opposite sign from this one. Okay, so we have 9x squared minus 15x plus 25. So I squared the 3x, I got 9x squared. I multiplied the 5 times the 3, and I got 15x, and then I squared the 5 and got 25. Just remember, if this sign is positive, this next sign is negative. And that's it. And we just put a box around our answer, and we're done. All right, so problem number 12, it appears we have a difference of cubes, but we need to factor out this 2 first. All right, so that's something that we're going to need to do first. And also, we need to factor out this negative sign, because we don't want a negative sign in front of our x cubed. So we're going to factor out a negative 2. All right, so that leaves me with the negative 2 times 216x cubed minus y cubed. And of course, like I said before, if you suspect you might have a difference of cubes, you need to check to see if the coefficients you have are perfect cubes. And 216 is a perfect cube. It's 6 cubed. So we can take the cube root of 216, and that gives us 6. The cube root of x cubed is x, and the cube root of y cubed is y. So that's our first term. So then we do our square, multiply, square. So square this, multiply these together, and then square this. Now remember, the sign here is going to be positive. It's always the opposite of whatever this is. So if this is minus, this first sign is going to be positive. The last sign is always positive. Okay, so we end up with 36x squared, which is 6x squared. And then we end up with a plus, because this sign has to be opposite of this sign, plus 6xy, and plus y squared. Just remember, doesn't matter if it's positive or negative here. Anytime you square something, it's always positive. So this right here is always going to be positive. And that's it. We put a box around our answer and we are done. All right, so problem 13 is a word problem. The world-renowned artist Mrs. Vaca was requested to paint a mural on the side of a historic building in New York City. The area of the wall is 18n to the fourth minus 60n to the third plus 50n squared. Determine the dimensions of the mural after taking out the greatest common factor. Okay, so basically we're just taking out the greatest common factor and then factoring what's left. And that's all you have to do. All right, so the greatest common factor we have for this expression right here is 2 and then n squared. So we factored out the 2n squared. We have 9n squared minus 30n plus 25 left. When I divide this by 2n squared, I get 9. When I divide this by 2n squared, I get negative 30. And when I divide this by 2n squared, I get plus 25. And then we have to factor this. Well, this is a perfect square, and this is a perfect square. So what we ended up with was a perfect squared binomial. So this square root of 9 is 3n, and square root of 25 is 5. And I need these to both be negative because the middle term is negative. The last term is positive, so these both have to be negative. And we end up with 2n squared times 3n minus 5, the quantity squared. So we actually have a perfect square mural that she's painting. So we know that the mural that she's painting is a perfect square. All right, so I wanted to take a look at problem number 16 because we have to do some manipulating here. First of all, we have to set this equation equal to 0. This is not a quadratic, this is a cubic expression or equation. So we're going to have to move some things. We're going to move all of this stuff that is on the right side to the left. And so basically what we're doing is adding or subtracting those terms to the other side so that we can set that equal to 0. Okay, once I've moved all the terms over, I get 2x to the third. I didn't have to do anything to that term. And then I added a 2x to the 3x. That gave me 5x. And then I subtracted 6x. And I also subtracted 6 from 9, and I got negative 15. Now I'm ready to factor, and I'm going to use a box. All right, again, we're going to factor out the columns first, then the rows. All right, so I have factored out the greatest common factor between these two terms here. This would be a 2 and an x. So I factored out 2x. In this column, I factored out a 5. In this row, I factored out an x squared. And in this row, I factored out a 3. So in order for this to be a negative 6x, this 3 needs to be negative. And in order for this 15 to be negative, this 5 needs to be positive. So we have 2x plus 5, x squared minus 3. So if I want to check to make sure that I've factored this correctly, I can always multiply these back together. So my final answer is 2x plus 5, x squared minus 3. All right, so if you didn't already catch it, there was a mistake on problem 12. So let's go back to problem 12 real quick here. And I want to correct that. Right here, I said that we factored out a negative 2. Well, when you factor out a negative 2, this sign inside this parentheses right here becomes positive. All right, so this should have been a positive. So this should have been the sum of cubes instead of the difference of cubes. And so how that makes the rest of the problem different is that this 6x is now plus y. Everything else is the same. The only thing different are the signs are different. So this first plus sign right here is going to make this next sign negative. So this sign right here should have been a negative sign. So it should have been plus, minus, and then a plus, because now we have the sum of cubes instead of the difference of cubes. So sorry about that mistake. I just caught it when I was reviewing the video. All right, in problem 17, we're going to solve by completing the square. The first thing I want to do is move this 1 over to the other side of the equal sign. So I'm going to move that over. That leaves me with 4x squared plus 8x equals 1. And then I'm going to complete the square. I'm going to make this into a perfect square. First, I have to factor out the 4 because I can't make a perfect square out of an x squared that has a coefficient. So I need to factor out the 4. So I'm going to divide everything by 4. So I get x squared plus 2x. And now I'm going to complete this square right here. What number do I get when I cut 2 in half? Well, I get 1. 1 squared is 1. So I'm going to need a 1 to complete this square. So on the other side, since I added 1 to the left, I also have to add 1 to the right. And also, since I factored out a 4 here, I also need to multiply this 1 by 4. So whatever you do to the left side, you have to do to the right. Okay, so now I'm ready to rewrite my expression. I have 4 times x plus 1, the quantity squared. Remember, a is 1 because if I cut 2 in half, then I get a 1. So that's what goes here in my perfect square binomial. It's half of 2. 1 squared is 1. So 1 plus 1 is 2. 1 squared is 1. That's how you know that this number is the correct number. All right, then we're going to go over here to the other side of the equal sign, and we're going to simplify this. 1 plus 4 is 5. And then I'm going to continue on simplifying this. And the next thing we're going to do is solve by taking the square root. So completing the square is only part of it. Now we have to solve by taking the square root. Well, I want to isolate the x plus 1 squared part of my equation, and so I'm going to divide both sides by 4. So that leaves me with x plus 1, the quantity squared, equals 5/4. Now I need to take the square root of both sides. So I'm going to take the square root of both sides, and I end up with x plus 1 equals plus or minus root 5 over 2. Because the square root of 4 is 2. All right, so last step is to subtract 1. So x equals a negative 1 plus or minus root 5 over 2. And that's it. Okay, just a hint here. Hint, hint. If you get a negative number inside here, don't forget that you're going to have to use the imaginary number I in your solution. So if this was a negative 5, for example, then I would have negative 1 plus or minus I root 5. So don't forget about that, because you might get one like that on the test. All right, now we're going to solve by taking square roots, which is very similar to what we just did when we completed the square. We solved by taking the square root once we completed the square. But this is a problem that has just taking the square root. So what we want to do is we want to isolate this x squared part right here. So we're going to have to move everything else out of the way. So the first thing I'm going to do is multiply both sides by 4. All right, when I multiply both sides by 4, This 4 times 1/4, that goes away. That was the whole point. And then negative 19 times 4 gives us a negative 76. Now I'm going to finish isolating x squared. All right, so I subtract 8 from both sides and I get 6x squared equals a negative 84. Then I divide by 6 and I get x squared equals a negative 14. Now I'm ready to take the square root. So when I take the square root of both sides, I get x equals plus or minus the square root of negative 14. Well, remember, if you have a negative number underneath your root, then that's going to be I. We're going to use our imaginary number. Okay? So plus or minus I root 14. And since I can't simplify root 14 anymore, I'm just going to leave it as root 14. And that's it. All right, for question 23, we're to find the discriminant and state the number and type of solutions. Well, if you remember from class, the discriminant is the part of the quadratic formula that's inside the square root. It's the b squared minus 4ac part. So we're just going to use that part of our quadratic formula to find the discriminant, and the discriminant gives us specific information depending on what kind of number we get. So we're going to go ahead and set this equation equal to 0 and find our a, b, and c. Okay, so after I set this equal to 0, I got negative 2x squared minus 8x minus 8. A is negative 2. B is negative 8. And C is negative 8. So now I'm going to use those numbers. I'm going to plug them into my formula, b squared minus 4ac. And I'm going to find out what kind of number I'm going to get there. It's either going to be positive, negative, or 0. And if it's positive, I have 2 real solutions. If it's negative, I have 2 imaginary solutions. And if it's 0, I have 1 real solution. All right, so I have negative 8 squared minus 4 times a negative 2 times a negative 8. And see how I have everything in parentheses? If you're going to put this in your calculator straight in, then you need to make sure that you use parentheses. If not, you're going to get the wrong number. So when I put this in my calculator using my parentheses, I get 0. And so I know that if I get a 0 as my discriminant, in other words, in my quadratic formula underneath the square root, I get a 0. If that happens, that means that my parabola is sitting on the x-axis, the vertex is on the x-axis, so I have only one real solution. So I would write one real solution. Okay, I'm going to do number 24, another example of this. Okay, in this problem, I get 8x squared minus x plus 3 equals 0. So 8 is my A, negative 1 is my B, and 3 is my C. So when I plug this into my formula, b squared minus 4ac, I get a negative 1 squared minus 4 times 8 times 3, which equals a negative 95. And since my discriminant is negative 95, that means I'm going to have 2 imaginary solutions because my square root is over a negative number. So that's going to give me 2 imaginary solutions. All right, in problem 27, determine if the quadratic equation was solved correctly by completing the square. If not, state the step that was a mistake, or where a mistake was made, or write none in the blank. So first of all, we need to check to see where the mistake was made, if there was a mistake. So we're going to take this step by step. So if I'm just working this problem on my own without even looking at what the steps are on here, that might be a good idea to do that. Just work it out on your own first and see if you get what they got. Okay, so that's what I'm going to do here. And if I don't get what they got, at least I can determine which step they missed. Okay, so as you can see, right off the bat, the very first step, we have a mistake. So this person here, they made a mistake when they added 52 to both sides. If you add 52 to both sides, you should get 59, not negative 45. So right there is a mistake. So right away in step one, there was a mistake. So, of course, everything after that is going to be different. And all of this is going to be incorrect for this person because they made a mistake in the first step. So, my recommendation when you're doing this problem on the test is that you go ahead and work it out for yourself step by step on the side, and then look at the problem to see if you have anything different from what the problem has. And you'll be able to identify which step if there's a mistake, which step it's in if you do that. If you do it step by step, then you should be able to figure it out. Okay, so that's all we're going to do for the review. If you have any questions, make sure you come to tutorials before the test and get some help and get some practice. I would highly, highly recommend that you work all of these problems on this review, and especially focus on special cases, perfect squared binomials, those kinds of things. You have to be able to recognize those special cases and recognize when you have a cubic or a perfect square. So if you have any questions, make sure you ask them before the test. And we may have a shortened schedule on Thursday, I'm not sure. But you might also want to practice some of those calculator tricks that I talked about. Make sure you know what buttons to push, because I'm not going to tell you on the test. I'm not going to help you with the calculator. If you don't practice before the test, it's on you. So good luck with the test. I hope you do well, and just practice, practice, practice.